Hi, this is Alyssa Kroll in Math for Elementary Teachers 221, and this is the Chapter 2 Teach It assignment, and I'll be doing problem 2-1A, number 15. So I'm just going to move the camera down so that we can get a clear shot of our piece of paper here. So the problem reads, complete the truth table below to determine whether the negation of P and not Q is the negation of if P then Q. So I kind of divided this problem into 3 steps just to make it easier to solve. So the first step that I have is to find out what negation means, because if we don't know what that means, then solving the problem is going to become a lot more complicated. And so the definition that I have written down for negation is the exact opposite or reverse value of an item. And so when we're filling out our truth table in regards to that, if we would have a true statement, then the negation would be false and vice versa. And so that's just something to help us out as we move along here. So the first step in figuring out the truth table is to find the values for just the regular P and Q statements. And so our values for P start and go true, true, false, false. And then our values for Q go true, false, true, false. And that just allows us to see the different situations that can happen between our P and Q values here. The next part of the truth table is to figure out the negation of Q. And as we said before, that's just the exact opposite. And so our value for Q originally is true, so the negation would be false. Second value is false, so then it'll become true. True will become a false, and then the false will become a true. So that statement is then negated for that step. Our next part of the truth table is P and not Q. And our rule for and goes that if both statements are true, then the statement will be true. If any value is false, then our statements will be false. And so we're going to look at our values here. Our first 2 are true and false, so that part is false. Then we have a true and a true, so that is true. We have a false and a false, so that'll be false, and a false and a true, so that is also false. So our values for P and not Q read false, true, false, false. Then we have to find the negation of P and not Q. So as we said before, we're just going to reverse those values of P and not Q. So we start out with a false, so that'll become true. Then we have a true, that'll become false, and then our last 2 falses will become true. So we have that part figured out. Now we have to figure out our if P then Q statement. And this is kind of the trickiest part of doing a truth table, is our if P then Q statement, just because the rules are a little bit different. So the rules for our if then statements go, if both values are true, then the statement will be true. If the first value is false at all, the entire statement is true, regardless of what the second part of the statement is. And if our first value is true, but our second value is false, then that part of the statement will be false. So we're going to look at this, and we're going to look at our P and Q. So our first 2 values are true, so that part will be true. Then we have our true and false, and since our true comes first and then it goes our false, we're going to make that part of the statement false. And then we have a false and a true, and so since that first value is false, that'll be a true statement. Then we have a false and a false, and since they're both false, that'll also be true. Our final step in our truth table is figuring out the negation of if P then Q, and as I said before, we're just going to reverse those values. And so we have a true, that'll become a false, we have a false, that'll become a true, and our last 2 values are true, so those will both be false. So I'm going to circle the parts that we need to look at here, which is our negation of P and not Q, and if P then Q. So for a negation, we have to make sure that our values are exactly opposite of each other in order to figure out what this problem is asking us to do. And so we're going to compare our values here. So we have true and false, false and true, true and false, true and false. So these 2 statements do happen to be negations of each other. So I'm going to write that down quick. These 2 statements are negations of each other. And so that is our answer to the problem. We had to complete the truth table and figure out if they were negations, and they in fact are. So we have figured out this problem. Thanks for watching.